James Webb has done it again. While the most powerful space telescope of all time was looking at a distant exoplanet, it identified a telltale signature that points to the existence of extraterrestrial life. But how did the experts track down this sensational discovery, and does the exotic water world K2-18b finally provide the answer to mankind's oldest question? What is a cult trash movie with Kevin Costner? For cinema fans, it is a promising candidate for astronomers when it comes to the question of the existence of extraterrestrial life. The problem, however, is that the corresponding water world has so far only been confirmed beyond doubt on the big screen. In the gigantic expanses of space, clear proof of a planet covered in roaring masses of water has yet to be found. Yet in theory, there are several potentially life-friendly ocean planets in our immediate cosmic surroundings. In principle, planets that form in the outer regions of a protoplanetary disk should each consist of 50% water in silicates and thus resemble so-called dirty snowballs. Under certain circumstances, however, it is possible for such planets to migrate towards their star, where they practically melt into water planets. This fate could possibly have befallen the exoplanet JG1 BAFTA. All observations by the Hubble telescope have shown that its atmosphere consists mainly of water vapor. However, K2-18b is now also strongly suspected of hiding a rippling secret. Located around 124 light-years from Earth in the realm of the anomalous red dwarf K2-18, the alien planetary world was discovered in 2015. In detail, the celestial body could be in the format of a super-Earth or a mini-Neptune. But before we get it wrong, the term super-Earth only refers to the mass of the rocky planet and does not make any statements about its surface composition or even its habitability. Astronomers refer to many Neptunes as gas dwarfs that are smaller than Uranus and Neptune and have a dense hydrogen-helium atmosphere. In the case of K2-18b, we know that strong evidence of water vapor has been identified in its atmosphere, so this could be the first exoplanet with known water deposits that are also present in liquid form. After the celestial body had already been examined by the Hubble, Kepler, and Spitzer space telescopes, it was time for Webb to carry out further spectroscopic measurements of the atmosphere in 2023, resulting in a spectacular discovery. K2-18b could actually harbor lithium, potential biosignature. Basically, the experts almost go into raptures when they talk about K2-18b. The planet receives almost the same amount of solar radiation as Earth, and the surface temperatures there are probably also similar to those on our planet. All in all, the celestial body could therefore offer ideal conditions for the development of life, but the extent to which this assessment corresponds to reality remains to be seen. As things stand, we cannot say with absolute certainty whether the potential ocean planet is really home to extraterrestrial inhabitants or not. All the more exciting, therefore, is a possible biosignature that researchers led by Shongmin Ai from the University of California in Riverside uncovered last year using Webb's near-infrared spectrometer. In detail, the spectral signatures of methane, carbon dioxide, and last but not least dimethyl sulfide DMS for short lay dormant in the data sets. This sulfur-containing organic compound was the proverbial cherry on the sundae for the experts, because dimethyl sulfide is in fact typically of biogenic origin, which means it is formed by living organisms on Earth. The compound is produced by marine plankton and during the decomposition of organic substances. Even if you can't see it with the naked eye, you've almost certainly come across the molecule before. It is considered to be the main supplier of atmospheric sulfur, significantly involved in cloud formation and producing the typical sea smell that we encounter on the beach. If the detection of DMS on K2-18b is confirmed beyond doubt, this could therefore provide urgent evidence of extraterrestrial life. However, researchers are currently exercising a certain amount of restraint, and for good reason. In fact, the corresponding signal in the data was not particularly pronounced, and it only became apparent when the data was analyzed in a very specific way. Future analyses will therefore have to show how watertight the evidence to date really is. For their most recent study, the research group reconstructed K2-18b and its possible biochemistry using several models. In these models, the experts simulated the ocean and the atmosphere, investigating how much DMS the potential organisms would have had to produce for it to accumulate in the natural gas envelope. The researchers also looked at where exactly it accumulates in the atmosphere and how quickly it is broken down again by radiation. At the end of the study, the result was that biogenic sulfur gases can in principle accumulate on such hydrogen-rich celestial bodies to such an extent that they are detectable to us. Yet this finding has a decisive limitation. in order to detect the corresponding concentration on K2-18b. The DMS production by extraterrestrial organisms would have to be at least 20 times higher than on our blue home planet. The reason for this is that a large proportion of the compound is directly broken down again by photochemical decomposition under the influence of sunlight. However, at higher concentrations, which would be quite realistic on ocean planets, a protective effect occurs due to the decomposition products of dimethyl sulfide. In other words, the molecules act like a natural protective shield that protects the lower layers of the atmosphere from further degradation. Why the near-infrared spectrometer is unsuitable for further investigations given the outstanding technical characteristics of the James Webb Telescope is unexpected to say the least. Chongmin does not believe that Webb's near-infrared spectrometer is suitable for investigating the DMS signature of K2-18b in a revealing way. Although the near-infrared spectrometer was used for this very purpose last year, the corresponding signature presented itself in a special line at a wavelength of 3.4 micrometers. As a result, the signal strongly overlapped with that of methane, and the values of the two molecules could not be clearly separated. However, the experts emphasize that clear detection is possible in principle. After all, DMS and its accompanying products also produce signatures in the mid-infrared range between 9 and 13 micrometers, and conveniently, this is exactly the range in which Webb's mid-infrared spectrometer can play its technical trump cards. It is expected to target K2-18b this year. But before that happens, the interim conclusion is that the team has discovered that extraterrestrial organisms on water worlds such as K2-18b could indeed produce detectable biosignatures. However, the data collected so far is not conclusive, and the results of the upcoming investigations will be all the more exciting, hopefully bringing us one step closer to the answer to what is probably mankind's oldest question. Are these the very first stars in the universe? The following discovery shows that the instruments of the James Webb Telescope are not only suitable for unraveling the mysteries of life on distant planets, but also for getting to the bottom of the oldest secrets of the cosmos. Astronomers have identified the spectral signature of the earliest generations of stars in the galaxy 13.4 billion light-years away. The Dark Ages were followed by stellar billions a few hundred million years after the birth of the universe. The first stars formed from hydrogen and helium. The glittering celestial bodies dispelled the cosmic darkness of the past and ushered in an era of reionization. In the same breath, the first heavy elements also formed in the massive but comparatively volatile giant stars. For experts, tracking down the first generation of stars that emerged from the untouched gas of the early universe is one of the most important research goals of all. So far, however, astronomers have only been able to detect remnants and possible radiation effects of the so-called population 3 stars. This is mainly due to the resolution of our telescopes, which is simply too low to detect stars at such enormous distances. But now the search for stars has been enriched by another detection technique. Recent models suggest that population 3 stars could have been formed in the residual clumps of untouched primordial gas of later galaxies. If one follows the theoretical predictions, the gas clumps of desire should be found in the halo of galaxies. With this knowledge in mind, the experts from the University of Cambridge turned their attention to the galaxy GNZ11, which is generally considered to be one of the earliest known galaxies at a distance of around 13.4 billion light-years. This gravitationally bound collection of stars and company already existed 430 million years after the Big Bang. The experts used the near-infrared spectrometer to identify the characteristic spectral signatures of the population 3 stars. These can typically be recognized by their broadened spectral lines of ionized helium and the complete absence of spectral lines of heavy elements. And lo and behold, the near-infrared spectrometer actually revealed an area in the halo from which intense helium-2 spectral lines emanated. The fact that the researchers found nothing but helium there indicates that the gas clump must still be quite pristine, and since the zone of the excited helium gas is also located at a great distance from the active galactic nucleus, the black hole, there could be ruled out as the originator. It is therefore most likely that the helium is excited by those intensely radiating young giant star clusters that lie dormant within the gas clump. On paper, the relics of primordial gas can collapse and then form population 3 star clusters, and follow-up studies should indeed confirm this scenario. Ultimately, the researchers may have identified the direct signature of the very first generation of stars in the halo of GNZ11 for the first time ever. In the future, the experts want to continue observing the galaxy to find out even more about the stellar pioneers and their formation processes. If you want to continue watching videos on our channel, you should definitely click the subscribe button now, become part of our community, and stay up to date from now on.